in order to eventually handle larger calculations where we would need some sort of order of operations, we're going to first have to talk about a few odds and ends. One of the things that could show up, we've already touched on, the absolute value, which again was in its simplest form, take the inside number and turn it positive. But we also have some other things that could show up in these calculations that we want to be aware of. The first of those is what we've referred to as either exponents or powers. These are very special multiplication problems. Multiplication problems like 3 times 3 times 3 times 3 times 3 times 3 times 3. It's special because it only uses the number 3. But it's annoying because it's just so darn long to get across the idea that we want to do the 3 times 3. How many 3's do we really have? We have 7 of them. Well, can't we just mention that we have a 3 and that there are 7 of them and that they need to all be multiplied together? Well, that's what we'd like, so that's what we create. We create a shorthand or symbolic version of that, which is the 3 that's part of our multiplication problem appears as a regular, normal-sized, and normally written 3. The fact that there are 7 of them, well, that's the new and different sort of thing. So we're going to take that 7, we're going to make it a little bit smaller, and we're going to put it at the upper right. And we're going to read this 3 to the power of 7, or 3 to the 7th power, or we could also just say 3 to the 7th. It gets across the idea, though, that we have a special multiplication problem, and the 3 would be referred to as the base, and the 7 would be referred to as the power or the exponent. There are only 2 different areas with powers where we don't say to the power of or to the such and such power. And that would be for these 2 special situations, power of 2 and power of 3. Because they connect to some geometry, we can shorthand those or nickname those. Squared for our power of 2 and cubed for our power of 3. So for instance, 5 with a power of 2 attached to it, we could say 5 to the power of 2, 5 to the 2nd power, 5 to the 2nd, or we could nickname it 5 squared. 4 to the power of 3, well, we could say 4 to the power of 3, 4 to the 3rd power, 4 to the 3rd, or we could nickname it 4 cubed. Those are the only 2 that have nicknames or shorter versions. All the rest that we would have, we would read by referring to the power in some way. Relating to a power of 2, we also have this notion of a square root. So the symbol that we have here around the 16 is referred to as a root or a radical symbol. And we're going to be working with very nice square roots. What this really means for us, the symbol is a shorthand also. It refers to a question like this: what number do we square in order to get a 16? And we could rephrase that a little bit. What number to the power of 2 gives us a 16? Or what number to the 2nd power gives us a 16? We could say blank times blank equals 16, but we have to have a side note there that when you fill in the blanks, you've got to have exactly the same number. So blank times blank gives you 16, but the same number goes in each blank. Well, 2 times 8 doesn't work, 1 times 16 doesn't work, 4 times 4 works, or 4 to the power of 2, 4 times 4, 4 to the 2nd power, 4 squared. So 4 answers this question. So when we give the square root symbol and the 16 underneath, we say the square root of 16 would be equal to 4. A couple other examples here that you can see. Again, we've got different questions that would relate to this Well, we have this square root symbol, we have an 81 underneath, so the square root of 81. That's a short version of asking ourselves the question, what number raised to the power of 2, or what number squared, would give us 81? Blank times blank is equal to 81, but we've got to fill in the blank with exactly the same number. Well, remembering our times tables, we know that the answer to that question is 9. And then finally, square root of 144. What number raised to the power of 2 would give us 144? Remembering our times table, the answer to that is 12. So now we've taken care of the odds and ends, we can go ahead and put together what we call our order of operations. We have an order to how we would attack calculations so that we can work through things and so that everyone would be able to get the same answer and that it would be the correct answer. And the order of operations, well, it's kind of along the lines of strength and what we can get access to. So there are a bunch of different symbols that we've seen that can trap things, parentheses, brackets, braces, or you could say curvy brackets, absolute value bars, literally like prison bars, trapping things inside of them. When these show up, we wouldn't be able to work with any of the numbers and any of the calculations that are outside of them until those parts get taken care of. So these would be the strongest or the highest priority things that we would want to work out. Now, if they're there, okay. If they're not there, okay. We still need to have some sort of order to all of the other things that we would want to worry about. So the rest of our order of operations takes care of how do we work out things that are in the parentheses, brackets, curvy brackets, absolute value bars. How do we work out things that might be outside of them? What is the highest priority? What's the lowest priority? So the rest of this is dealing with those essential questions. What do we really look for first, whether it's trapped inside or if there's no trapped inside stuff? What do we look for first? We look for those special things that we were actually just talking about, the exponents and the square roots, those very, very special things that are connected to multiplication and division issues. And then we actually move on to multiplication and division. But there's something very important about dealing with multiplying and dividing pieces. They're equally matched, essentially. And which one do we deal with first? Different problems have multiplying that might show up in front of division. Other problems have division that might show up in front of multiplication. Do we always work one versus the other? Or is there something else going on? Well, it turns out that there's something else going on. We're reading. So we use the normal convention of reading that as we go from left to right, things that are equally matched, multiplying and dividing, we're going to work them as we read them. So if we read a little multiplication part first, we're going to work that multiplication part first. But if instead we read a division part first, we're going to work that division part first. Once all the multiplying and dividing has been cleared out, then I would be looking at any adding and subtracting that would be left over. And they are equally matched to one another. So again, we've got to have some sort of agreement for how we're going to work them out. And it's the same agreement. Whichever we read first is what we do first. These are key things for us to remember. So some folks like to shorthand the order of operations. And remember, please excuse my dear Aunt Sally. Other folks might like instead a bit of advice, perform every minute detail and succeed. But one of the key things that you don't want to forget about is that, again, the multiplying and dividing are equally matched. So whichever one of those things you read first, you do first. When you're ready to handle any adding and subtracting, whichever one of those you read first, you do first. So those little arrows that are underneath the letters trying to help me remember those very special components. Informally speaking, you could say that working these calculations, it's the math version of a prison break. That anything that is trapped inside, you would want to free up. Let your math help you escape from the jail cell, then the cell block, then the building, and then the fence. And that while you are doing that work, again, very informally speaking, you want to worry about things that show up from left to right. So kind of a loosey-goosey way of talking about it, but still a helpful idea for us. Now, because of this being far more complicated and having a lot more different variations than a lot of the other problems that we have seen so far, we want to make sure that we're very thorough in going over a lot of different examples, seeing a lot of the different things that could show up when we work our own problems. So, let us start with something that is short and sweet, but still has a very important sort of element to it. We want to read our problem so that we know what is there and we can compare it to our order of operations. Figure out what we need to do first and do that. So when we read this particular problem, because we don't have any other special symbols, we just read 50 divided by 2 times 7. Because there's nothing that is trapping one part of this or another part of this. We don't have anything immediately obvious about which of these two actions do we do first. Do we do the divide or do we do the times? So we think about our order of operations, we refer back to it and say, well, things that are mentioned are multiplying and dividing, and that arrow underneath is reminding me to do them as I read them from left to right. So the first thing that I read here is the 50 divided by 2. So the first part of this calculation to work out is the 50 divided by 2. Then I'll go ahead and copy the other part down that we didn't use yet, the times and the 7. And now what I have when I read this is just a single calculation to work out. 25 times 7 gets me 175. This would be a very different problem if we had worked out the multiplying first and the dividing second. We would get a very different answer. That answer would not be correct with the way that this problem is originally written out. The key element here is remembering that for multiplying and dividing, we do it as we read it from left to right. 50 divided by 2. That's the first thing that we read. That's the first thing that we worked out. And then we do the multiplication in a separate step. In this particular example, when we read through things, again, we can be very deliberate about this. Parentheses, 5 power of 2 minus 2 times 7, parentheses, plus 18 divided by 2. Based on what we read, back to the beginning of our order of operations, we have parentheses that show up. So we're going to basically put on blinders and narrow down and only worry about what is inside those parentheses for the first little bit of the work that we do. So I'm not concerned about what appears outside the parentheses for the time being. I need to free up the stuff that is inside the parentheses and get a final answer here. So only reading that now, 5 to the power of 2, so power, minus 2 times 7. So there are 3 actions that I have to worry about here. There's my power, there's my minus, and there's my times. Out of those things, which shows up first in my order of operations? Well, E is for exponent. Exponent's another word for power. So the first part that we have to work out here is going to be the power. Power of 2 means 5 times 5, and 5 times 5 is 25. Now I want to copy down all the rest of the stuff that shows up in the problem. I'm not going to work out anything else. I'm going to do just one little step at a time. As I'm getting used to the order of operations, I don't want to try to do too much at once, possibly make a mistake by going out of order. So, one little step at a time. I took care of the power, recopied all the rest of the stuff, symbol for symbol. And now I'm going to read this, again, focusing in on what's inside the parentheses and only worrying about that for the time being. 25 minus 2 times 7, so a minus and a times. Based on my order of operations, multiplication comes before subtraction. So I'm going to go ahead and take care of that multiplication. 2 times 7 gives me 14. And then I'm going to go through and copy down all the rest of the stuff, symbol for symbol, that I did not touch yet. And then, again, I'm going to read what's inside the parentheses, and now I see that there's only one last calculation to worry about in there with the subtraction. 25 minus 14 gives me 11. So I can ditch the parentheses around the 11. I've freed that up, and I can go ahead and copy in the rest of the stuff that was outside the parentheses. And now read all of this together to figure out what I do next. 11 plus 18 divided by 2. So my 2 actions, plus and divide. Divide comes before add. So I go to the 18 divided by 2. 18 divided by 2 will give me 9. I go ahead and copy down the other stuff, and that leaves me with my very last calculation here. 11 plus 9 is equal to 20. Now for a problem that has much more going on, I'm going to want to read through and again be very deliberate about reading things. Bracket, parentheses, 5 squared minus 2 times 7, parentheses, plus 18 divided by 2. Bracket, parentheses, 10 plus 2 times 5, parentheses. My order of operations tells me P for parentheses, brackets, anything that gets trapped I'm going to have to worry about. So I have things that are trapped inside a set of brackets. Inside that set of brackets, I have things that are trapped inside parentheses. Well, rather than being a complete devil about it, notice that what's really inside the brackets is exactly the problem that we just finished working out. So, had we been doing this from scratch, we work out what's inside the parentheses, we work out what's outside the parentheses, but still in the brackets. We come up with that answer, which we already have. All the things that are inside the brackets work out to give us a 20, which means that we can go ahead and drop the brackets at this point. All of those things give us 20, and we can go ahead and just copy down the rest of what shows up in this problem, which is another set of parentheses. So we laser focus on that, and we've got plus and times. According to our order of operations, times comes first. So we go ahead and do the 2 times 5 and copy all of the other pieces down. Then we do the plus that's inside those parentheses. Well, now we're going to need a little something that we haven't directly mentioned before. How the 20 would be connected with, well, turns out it's another 20 here. What do we have going on when we have a number written beside a set of parentheses, or when we have a set of brackets written beside a set of parentheses? Well, without any symbol showing up, we're going to default to multiplying. So, if we want to get rid of the parentheses around the green 20, then we would need to remember to put in, by default, a multiplication symbol of some sort. And 20 times 20 gives us our final answer here of 400. The examples so far have all had whole numbers, or positive whole numbers, if you want to throw a little extra emphasis on there. Well, what about negative numbers showing up? That could definitely happen. What do? Well, we follow our order of operations. We just remember the things that we've talked about as far as adding and subtracting with negative and positive numbers, multiplying and dividing with negative and positive numbers. So for the adding and the subtracting, we want to remember to think of money problems. For the multiplying and the dividing, we want to remember that one negative number in our problem gives us a negative answer, and that two negative numbers in our problem gives us a positive answer. So we go ahead and throw those in the mix as well. We start reading through things. 4. Officially, that's times, even though there's nothing written down. Times. The curvy bracket. Ooh. The square bracket. Ooh. 8. Parentheses negative 4 minus 3 plus 9. Bracket. Minus. Bracket. Good gravy. Parentheses negative 3 parentheses. Parentheses negative 2 parentheses. Plus 6. Bracket. Curvy bracket. We got a lot of stuff trapped in a lot of different ways. So take another look through and see what we've got going on. We've got curvy brackets trapping a bunch of stuff. Inside of those curvy brackets, we've got one set of square brackets. We got a second set of square brackets. Let's deal with the first set of square brackets and see what's going on there. So we put on our blinders and focus in on what's going on inside this set of brackets here. 8 parentheses negative 4 parentheses minus 3 plus 9. What we seem to have going on here, well, there's a set of parentheses to worry about, but what's inside those parentheses is only a number. It's a negative 4. No action. So what I really want to do is reread this. 8 times negative 4 minus 3 plus 9. According to my order of operations, times is going to come before the minus and the plus stuff. So the very first thing that I would want to begin working out is going to be the 8 times negative 4. Positive times a negative is a negative. 8 times 4 gives me 32. And then I'm going to copy down all of the other symbols without changing or doing any extra calculations. Because again, I want to be very careful with what I do so that I do not accidentally make a mistake and do things out of order. Still looking inside that first set of brackets, I have the minus and the plus that are showing up there. According to my order of operations, I do what comes first. So we're going to work out what we would read mathematically as negative 32 minus 3. But when we were working with adding and subtracting and had any sort of negative stuff showing up, we thought of these as money problems. So I owe 32 and I owe 3. That means that overall we're going to owe. It means that we're going to have to take the 32 and add the 3 to get a negative 35. And again, that's the one part that we did, so that is the only part that we work out. Everything else gets copied down exactly like it already looked. Inside that set of brackets, we are now finally down to one last calculation. Negative 35 plus 9 is the math version of that. But the money version of that, I owe 35, I have 9. I'll still owe money, but I'll have paid some of it off. So 35 minus 9 means that I would owe 26. So negative 26. I can ditch the square brackets, but I do have to leave all of the other symbols that show up. This means that I can also move on to the other set of square brackets, reading what's inside the other set of square brackets. What's inside the parentheses are just numbers, so I can read this as negative 3 times negative 2 plus 6. Times and plus. According to my order of operations, times comes first. So, negative 3 times negative 2. Negative times a negative is a positive. 3 times 2 is 6. And again, I'm going to copy down all of the other things that showed up without doing anything else extra. Inside my brackets, we have the 6 plus 6, which is normal. We do not need to think about money in order to get the 12. Though we could, we have 6, so overall we have 12. I want to copy down all the rest of the symbols that appear around that, which means that we will now have things that are trapped inside of our curvy brackets still. So what's trapped inside the curvy brackets is only a single calculation. Negative 26 minus 12. We rethink that as a money problem. We owe 26, we owe 12, so we will owe. We take the 26 plus the 12 to get that full debt of 38. And we have the 4. We can get rid of the curvy brackets, but we would need to remember that we would be multiplying 4 times negative 38. So our final answer would be a negative, and the 4 times the 38 would actually give us 152. So final answer, negative 152. A lot of folks feel that the more things that are going on, the more difficult a problem can be. Well, don't let things overwhelm you. You're trying to use your order of operations to do bite-sized pieces. Don't cram the whole steak in your mouth and choke on it. Take bite-sized pieces, and eventually you will chew up the whole thing, and you'll be done. Well, a problem like this next example looks very unusual in that it now has a whole lot more going on, but it's not written just straight across like those previous examples were. It's got stuff above a division bar, it's got stuff underneath a division bar, and that makes things a little bit more strange for us. So let's try to rethink what this really means. Division has to have, well, 2 numbers, a dividend and a divisor. Top number, bottom number. So that gives us a clue that what we'd really like to do for a problem like this is figure out what the entire top stuff would work out to be. figure out what the entire bottom stuff would work out to be, so that at the very end we would be able to do the division. And that is in fact the case, but officially speaking, we can write things out in a single line, and it means using some extra brackets and a more traditional division sign. Well, in case things are given to you the way that that original example is written, a three-pronged plan of attack. Work out the top stuff according to your order of operations. Work out your bottom stuff according to your order of operations. Take those two numbers and put them together as a division problem and work out your overall final answer. So that original problem has a final answer. And to do one of these together, let's take a look at this. What we have showing up on top is the first part of what we would want to work through. Up on top, we have a parentheses, -4, parentheses, power of 2, minus, parentheses, -3, parentheses. Looking at that, and only that, our order of operations, as we were reading through things, we had a power of 2, and we had a minus. Well, according to our order of operations, the first of those that we would work out is that power of 2. This brings up a very important thing about powers. What's right in front of the power of 2 is a set of parentheses. So whatever is inside of that set of parentheses must be used in our special multiplication problem. Blank times blank. Well, what's inside of those parentheses is what we use to fill in the blanks. -4 times -4 is going to give us, negative times negative is a positive, 4 times 4 is a 16. It's very important for us to recognize that in this particular problem, the parentheses being present and in front of that power of 2 means that the negative and the 4 are being used in our special multiplication problem. Then, as we're reading through things now, we hear that very special trio minus parentheses negative, and we got to remember that's that one special thing to look out for when we were worried about our adding and subtracting problems, so that we would have, in this particular case, a 16, and in the middle, a big old plus sign, followed by a 3. So everything up on top works out to give us a 19. We'll need that in a few more minutes, but we're going to have to work out the second part of our plan of attack, which is what is going on with the calculations underneath of our long division, or not long division, but division bar. So if we go ahead and copy this down and look only at this and read this to ourselves, -2, power of 2, plus bracket, parentheses, -36, parentheses, divided by, parentheses, -12, parentheses, bracket. Well, the brackets are trapping things. The parentheses, however, are not. So the first thing that we would really need to worry about is literally what is inside those brackets. What's inside those brackets, excuse me, let me use the blue, is a division problem. A negative divided by a negative is a positive answer. So we will be getting a positive 3 from that. We read what we have now, negative 2, power of 2, plus 3. We have power, we have plus. According to our order of operations, the power comes first. And looking at this, the power has a 2 immediately in front of it. No parentheses, just the number 2. So our special multiplication problem is only going to use the number 2. The negative that appears is just going to hang out at the very front. So if that negative is hanging out at the very front, then that means that we've got 2 times 2 gives us 4. So a negative symbol hanging out in front of that green 4 and a plus 3 coming afterwards. We use our money idea. I owe 4, I have 3, so overall I will owe 4 minus 3 is 1, I'll owe 1. That gives me the other part of my problem so that I can do the third prong in our attack, which is to take the answer from our first set of work and divide by our answer from the second set of work. 19 divided by a negative 1. Positive divided by a negative will give us a negative. 19 divided by 1 gives us 19. Again, to backtrack very quickly and emphasize those 2 very important parts that are related to the powers. If you have parentheses, you are using the negative and the number with the power. If you do not have a set of parentheses, then you are not going to use the negative. You are just going to use the regular old number and leave the negative sitting out in front. So you want to make sure that you're careful about reading those problems. That is a very common mistake for folks to incorrectly work through powers that have negatives and may or may not have parentheses. All of the examples that we've worked so far have been order of operations problems that were directly given to us. There's an indirect way for them to give you order of operations problems, and that is by having variable expressions and specific numbers to put in place of the variable letters. By variable, we are referring to a letter that represents some sort of unknown number, and they are going to, for the time being, give us numbers to put in and see how things would calculate out. Or another way of putting it is, we want to evaluate an expression that they gave us when they have given us some numbers to use. Make sure that you're careful when you insert your negative numbers. And in fact, if you can use any sort of highlighters, colored pencils, or colored pens, that can help you make sure that you're keeping track of things. So in this particular expression, what we want to do is make sure that we replace the correct letters with their correct numbers. We have a set of parentheses, then we see an X. Let's replace the letter X with the number that they give us, which is a 4. And that's going to be followed by a plus 7y. Well, that means 7 times y. No symbol in between them means we default to multiplication. 7 times y. 7 times the specific number that they give us for y is 6. Parentheses divided by, and then we see the letter Z So the letter Z that they've given us is a 2. So we now have an order of operations problem, but we had to build a bit of it ourselves, given some separate pieces. Now that things are in there the way that they needed to be, our order of operations tells us to focus on the parentheses. Inside the parentheses, we have plus and times. Our order of operations tells us to do the times first, 7 times 6. Then we can go ahead and do the adding. And when we do the adding, we can drop our parentheses. And then last, we can do our division and get our final answer. So our final answer here, 23.